Hey, what is up guys? Welcome to Software Engineering with Karthik. So this is another video in the multi-part video series. In these video series, we've been building a network library from the scratch. As I'm building, I'm explaining some of the reason behind my decisions and what are the design principles that is backing those decisions. So this way I can just talk about some of the software engineering principles that I have learned. If you have not got a chance to check out my previous video, I highly recommend it because this video is also going to be a continuation of my previous work. At least clone the repository. I'm going to add the repository link in the video description. Just clone the repository. Get yourself familiarized with the code base at least. Otherwise, this video is also not going to make any sense, right? Okay, sounds good. Let's dive into our project. What do we have here so far? So far we have implemented 4 use cases. 3 are related to request response and error, and the 4th one is related to improving the URL request generation. So in this video, we're going to talk about some of the thing that we could do for a logging mechanism. I hope this is recording. Okay, yeah, there's a recording. So in the previous, in the beginning of this playlist or video series, I have mentioned briefly about some of the techniques that we could do for logging, because logging is one of the obvious dependency for the network library in a typical project. Because any project, if you're working in a product company or in any project, you will have to log your network request and response to some place, either some place where they can have a web platform or in fact even to a console itself, right? So this logging, usually the logic behind this logging is maintained in a separate library. So usually you will find a module or a library called logging or analytic or whatnot. Maybe most of the time I have seen that people include logging as a part of analytics, but anyway, you'll find it there. So if you notice that one of the goal for us, a success criteria for us, is to have a stable library. And the library, that means we have to adhere to stable dependency principle as well. So how do we do that? Is by reducing any dependency for this, direct dependency for this library. So basically the network library is not going to be dependent on any other library. If another library, if we need some other dependency, we're going to define a protocol or interface to define our own boundaries, and we're going to inject them via the builder, right? So that's what we're going to do. So that way our library, the network library, is dependency free. So with that being said, so logging is something that that we wanted to think about, right? So usually what do we have in logging, right? So maybe a logging, let's consider a model class logging model, how the logging model generally look like, right? So the logging model may have a public I don't know, class or a structure called logger or something. So this may have a static property, or maybe a instant property. Let's go with static for now. Log request, maybe, right? If you're logging a network request, then we can just consider this as a network request. Maybe a response. Response, things like that, right? Maybe you'll have some other parameters, like probably data or parameter This could be string or any whatever, and log level could be debug or verbosel or error or something like that. This is what usually a logging library would look like. Maybe another method called log error, right? This is what usually we will have. Then if this is the case, if this is what the public API of our logging library, then what we're gonna do here is that usually you will see this. So let's just say this is our network library. So usually what we're gonna do here is that we're gonna import logging. Sorry about the background noise there, because my puppy is playing with the toy. Okay, let's just say we have a class service. So this network service will receive a request, URL request, right? So in this place, we're gonna say, hey, now that I have a logging, I'm gonna say logger.log request. Something like that, right? This is what we usually do. But if you notice that then the network library is directly depending on logging. So that means if something goes wrong in logging, then it's going to destabilize our network library as well. So hence, our library is not considered as a really stable library. So this is the problem that we are going to solve in this video without any further delay. So now I hope this is clear. So now let's see how best we can just fix it, right? As always, we're going to do a use case analysis. I wouldn't say analysis, just let's write down a use case. So given a network service, when a request received, then the final request is sent, I don't know, probably, you know what, I'm thinking of using a publisher, so I'm gonna put it like that, is, you know what's emitted to a publisher, to a request publisher, right? That's the first one. When I receive so in a network library, we're going to receive a lot of requests. As we receive a request, what we're going to do here is we're going to emit that request, the final request, to certain stream. So whoever is subscribing to that stream, they're going to take over that URL request object, and then they're going to do whatever the behavior they want to do with that request. So it's up to them. So it's not a concern of a login network service, because if we write a use case, something like the final request is logged, that means what we are doing is that we are violating a single responsibility principle. Like, actually, it is not a single responsibility principle. It is called as common closure principle. So what it essentially states is that a library, it's a single responsibility principle in a steroid, right? For a component level. So what that means is that the library should only change for one reason or one theme of reason. That is the idea behind it. So if we do logging, that means the library does two things. One is networking, another one is logging, which is something that we don't want it to do. So what we're going to do here, we're going to keep things abstract, right? As far as the network library is concerned, everything is going to be abstract, right? That is, again, is one of our success criteria as well. All the public APIs has to be abstract. So given a network service, when a request is received, then the final request is emitted to a request publisher. And the same applies here as well, for response as well. When a response is received from server, then the response emitted to a response publisher. And also the same, obviously, you guys you might have guessed it already. This is going to be error received during, oh, server spelling right is wrong. So when a when given a network service, when an error is received during the call, error occurred. You know, we already have something similar. I want to copy paste it. During the call, then the response is emitted to, then the error is emitted to error publisher, right? So these are the use cases that we're going to implement. Let's move this thing down here below so that it can be visible. So these are the three things that we're going to do. So we're going to keep things abstract. So as we receive request and response and error, we're going to emit those things via a publisher, right? This can be either a request publisher. We can even combine all this network events. So you see everything is an event, right? It's a network event within the internal library, within the library. What we could do is we could just create a one single publisher and then have an enum. Let's do the implementation details later. Think about the implementation details later. All right, as usual, let's go to your unit test. You see, this test is growing, right? What we're gonna do here is I'm gonna create a new test for that instead. Oh, come on. This is something that Apple has to improve. Network event publisher, event tests. All right, network event test. That's good. Short. All right, import first. Let's import our network library and then import exe test, final, all the ceremonial code. Yeah. All right, function setup. Usually we're gonna have a bar. As usual, we're gonna have to mark, this is unit test, we're gonna mark the platform, mark URL session. This is gonna be there, and service network requesting. So that's what we're going to use, because only we're going to receive the request. Let's see, let's build our code. You know what, I could just copy paste some of the thing from here instead. Let's copy paste here, because everything is going to be same, right? Because we're not going to change the setup method anyway. Session provider, we don't need that. We could keep the info providers empty. All right, good. Make sure to import the combine as well, because we are heavily relying on combine. Otherwise this guy is going to complain. All right, let's see if this is building. It's building. It is building for test as well. Nice. Okay, let's write our first test. Test given a network network service, when a request is received, then the final request is emitted to a publisher. Emitted to request publisher. Okay, so sounds good. So what are we going to do here, right? So let's build a request. In fact, we can just copy paste that too. We already have this code already, guys. As I said in the beginning of this video is a continuation of previous code base as well. So just get yourself familiarized with the code, otherwise this what I'm doing is not going to make sense, right? So to just give a summary, so I'm just creating a URL and I'm creating a URL request, and I'm sending that URL request to the service, right? The service is going to be built via network service builder. So this is a builder pattern that I'm using. It is a nice way to abstract our implementation details. So this is what the consumers are going to use, right? This is how the consumers are going to configure and then use our network service. So this network service class is an internal class, right? So only the network service request, which network service conform to, is a public, right? That is the reason why I mentioned our goal is to have all the public APIs abstract. There's a reason behind it, but yeah, there you have it. Let's see. Let me open it again. Yeah, sounds good. So we're sending a request via send. So we have a start. The send method is going to provide us with the publisher. This publisher will have a network response and network error. So and also I have a start method, which is a utility. Well, let's import that as well. Network test utilities. So this network test utilities, yeah, you see it's color changed. It just calls a think operation. So and then put that cancelable in a bag, which is good. So if this is the case, what we wanted to do here is that we wanted to have a something called now the network service. We send that we need an entity through which we can subscribe, correct? We wanted to receive we wanted to have some sort of a request publisher or some sort to receive or send and receive a request, right? All the incoming request. So basically this is what we need, some sort of a publisher. Why don't we do one thing? Instead of calling a request publisher, let's refactor later. Yeah, so we want to have let's just say I have event publisher dot sync. Before I sending this request, I am going to do sync. So this sync is going to give me an event. So this event could be like a switch event case request. Let request, right? Our value, right? Now we can just compare if this is equals. So why don't we do the same thing that what we did before? We could add this guy some request ID. If that is the case, then we can just check if the receiving value have the same thing here. All right, we can check this guy here, right? So what I'm doing is that I'm setting a unique identifier in this request header, so that when I receive a event from the publisher, I can verify against it to make sure that I have received a request through the publisher, right? So now this is a asynchronous activity. Well, actually all our all our test, it runs synchronously, but I just want to make sure I verify this is event received false. Initially it is false, so I'm going to say true, it is received. So before I end this test, I'm going to make sure I just test this guy as well. Execute true, is event received, right? So this is ideally what I wanted to do. So we don't have the code yet, so I'm just writing this code. Maybe there's going to be error, so let's build this thing. You see, obviously, so we do not know what is this event publisher here yet, right? So now we need to find a way to add this event publisher from our public API, right? Obviously, the network service builder is how the consumers are going to access our network library. So what I'm going to do here is that if you're going to have to update this one. So when the network service builder builds a new network service, it provides us with a network requesting. But let's just say if we add this thing, right? So we could just add a publisher here. Any publisher event, never. We could add that, but the problem is that if you notice that if you add that, this network requesting, it is violating the single responsibility principle right away, right? So the name, the network requesting, it just clearly states that this protocol is going to be used only for network requesting, like only to send and receive send a request. Anything related to request is what we are going to add here. If you add an event publisher here, this is not relevant to network requesting at all. So that means we naturally have to write an alternative solution for this. So what I'm going to do here is I'm going to create a new public API that is called network events. Network event publish. Let's call it network event. And naming the file is always a hard job for me. Event, let's call it that way. I wish it changes automatically. Event, right? Let's call it enum. For a second I forgot what was the correct word. Case request. URL request. So this is the only thing that it is going to have. What else we can do? Now we have an event. We need a way for the consumer to obtain the publisher. If that is the case, then we need a publisher. We need some entity that holds the publisher. We need some entity that creates the publisher and holds a reference of the publisher as well. If that is the case, then what if we have something like a class? Let's start with that, right? Again, guys, this video that I'm doing, it's not scripted at all. I'm going to make mistakes. I'm going to course correct it. I'm going to clean up. So that's the format it is. I don't want it to, memorize some script and then record a video. Event, I don't know, stream for now. Okay, whatever. Maybe we can rename that later. Right. Structure. event stream. This is gonna have probably a publisher. It's called oh, why I have to combine. Any publisher, network event, event, never. So this is what we're gonna do. Let's just keep it like that. Why don't we just do this? Okay, so now let's just say event, network event. This is what our internal APIs are going to use. So if this is a publisher, then we're gonna have, I'm gonna create a pass-through subject. So this pass-through subject can be initialized during the init method. Whatever. You know what? Let's not do that. Okay. All right. So subject dot send event. So if I send this event to the subject, so this publisher is same as the subject, which is type erased. Okay, if we have something like setup like this, what is gonna happen is that we could just use this guy somewhere over here during the, because network service is where everything is gonna come down. So what we're gonna do here is we're gonna stream event stream. Let's put it here. Okay, so this is fine. So this could be, this is okay. So we will add, so this is, you know, in the send method, this is exactly the place where the request is going to come. So we're going to mutate all the requests. Well, actually it's not mutating, it's just, you know, adding more info to this request and purporting the final request. What we're going to do here is that before we're sending this to the server, this event stream can publish this event request with final request. Okay, so this event is going to take care of, so the network service don't have to worry about logging or anything, so this event stream will take care of it. So let's do that. You know, if you notice that from the beginning of this videos, in the beginning this send method does not contain anything, any business logic or any logic. It just purely contained this platform send request. But if you notice that it's just growing, right? So if initially it wouldn't, if you watch the video start, you may have felt like, okay, this sounds like over engineering. Why are we creating a couple of different entities? This one, each entity only contain a very few lines of code, right? But now if you look at the way that that every class and every file is evolving, it just adds up, right? So the code adds up. Now it would make sense to, you know, from the beginning, divide the responsibility between multiple classes, multiple protocols. So that's what, this is exactly what is the beauty of test-driven development. So we are letting the test drive the implementation from the beginning. So whatever the architecture that it produces, that architecture is going to be really, really good, that is suitable for the problem space here, right? That's what it is. So anyway, so we're just publishing it, that is fine. So now if that is the case, it's going to produce a compiler error, because this compiler error, in this compiler error, we are missing a event stream. We can create a event stream. create an event stream. I'm not sure if the stream is the correct one, but anyway. Now, if we return this, well, it is going to compile in the sense like it's going to compile here, but the tests are still, the test still doesn't have access to event publisher, right? So the network service have an event stream, but we're going to have to expose this. So now if you have to expose this, what the build method cannot do is that it cannot just return a network requesting, because the network requesting is just a request protocol, right? So it needs to provide, the build method needs to provide network requesting, and at the same time it has to provide us with the publisher as well for the consumer to access. So this way, so if that is the case, then the build method has to be updated. We have to introduce a new element, new data structure or something over here to provide both of them. We could use tuple because it's simple, but I wouldn't recommend using tuple. Instead, what I'm going to do here is that I'm going to create a module called network components. So one thing is going to be request service, network requesting. Another one is event publisher. This is what the consumers need, right? Let's import combine as well. Event never, this is what the consumers need. Why don't we just move this network component to the module? We have a module subfolder here. That is nice. Okay, network components, go back to here, just copy paste this guy. All right, import combine. All right, nice and clean. So if that is the case, we don't even need this in here. Okay, so now we have a event stream and then service. We're going to create the data structure, network component, service, and stream dot publisher, right? So we're going to create this and send it over to them. So this stream object is going to long live as long as the service lives. So because the service is holding the reference of stream, so we can directly send the stream publisher here, which is good. So instead of returning a requesting, I'm going to return a network component now this time, right? So now the implementation changed because the test is demanding this change. So that's how it is. The test is demanding a public API change, and so we're going to follow that. So if this is the case, let's build this. I'm pretty sure all our tests are going to fail at this time, fail to build. What's going on here? Reference, network, yeah, instrumentation test, everything is going to fail. Let's see. So the build dot, oops, sorry. Okay. Requesting dot serve. Oh, okay. So that is an internal property. Okay. Service. Okay. So this is what we're gonna do. Why don't we just take components? Network components. Components dot service. Let's copy this. This is gonna go away. Now we have to deal with this error. Okay, right. All right, sounds good. But we're gonna instead also let's store the event publisher. So this is the test where we are implementing. Oh, actually, this is not the test. I'm sorry about that. So this is fine. In our event test, we have to do it. Yeah. So this is the test where we are doing our use case implementation. Any publisher, did we import combine? Yeah. Network event, never. Nice. Let's store that as well. Components dot event publisher. Okay, so result of the call sync never receive a value. Event cannot find a recent request. Okay, cannot find a recent request. Okay, the value.url has to be a request this URL. Okay, okay. Okay, my dog is breathing heavily. I just want to check with them. Okay, let cancelable, store that so that the warning will go away. Cancel, whatever. We don't need that. So let's see how this works. Previously it was failing. This should, yeah, it's testing. Oh, nice. Okay, so I just want to make sure that let's look at the code coverage and then see if, oh nice, we still have 100% code coverage. The event stream is also reached 8 times. It reached. That is nice. Okay, there you have it. This is how we implement this one. Before we go to the next use case, I would like to do the clean. I would like to do a cleanup of this one. So we already have this start with bag. Why don't we do this? We already have a on value as well. So instead of doing that, we are gonna do here like this. Okay, right, nice. This is much more clean. Service dot, okay, this is good. Make sure it runs. Oh no, okay, cancelable. Make sure it runs. Testing. Nice. Okay, that works. So that's first request that we implement. If you notice that I have not introduced anything in this enum, I stopped writing more. I stopped writing a case, enum case here, as soon as my need has met. So this is the way. This is what I mean by strictly stop writing production code once your use case is satisfied, right? So usually we'll just say, hey, just in case, write response or something. Oh, come on. Response or a case error. We usually write that up front, but I don't want to practice that no more. I used to do that before, but now I don't do that no more. As long as my use case needs are satisfied or met, then I'm going to stop writing any more production code, right? That way we can just avoid any dead code. All right, so let's come back and then implement the next use case. The next use case is going to be given a network request. When a response is received, then the response is emitted to a response publisher. Correct. All right. Again, this is going to be same. This time we don't want to check request ID because we already verified that in the above test, so we don't have to prove that again. Then it's going to be redundant. So So this time we're going to have a response, right? If the response is received this you know what, let's keep the request here. Response, if we receive a response, then it is pass. Then if we receive a request, yeah, well, we can just ignore it. Yeah, for now. Yeah. Event is received. That's all we want to check. We don't have to check the response details there. We don't, because that's not our concern here. All we wanted to do is to just to check if the response is received from the server or not. That's all we're going to check. We're going to send a request. So we're going to prepare a request. Yeah, we're going to prepare a request, and we're going to send this request via our usual public API, and then we're going to check if we at all receiving a response from the event publisher. That's all we wanted to do. And also we wanted to verify if the event has received or not, because it is a asynchronous task. For our test it is synchronous, but the APIs are asynchronous, right? Okay. Let's see, this is going to fail obviously because we don't have anything called response here. Also, let's remove this one. Okay, sounds good. So there is no response here. Let's now introduce a response. Network response, right? We have a network response object. That object contains a payload for now, but maybe in the future we may add a public response, HTTP response. That's what we wanted to do, but now we don't need that, then so we're not going to add that. All right, so we have a response. We added that net response. Let's see how this reacts. It's going to fail because oh wait, hold on. It's going to fail here. In this case we can just respond. We can just ignore it in the previous case. Oh, come on. So this test is going to fail here because we're not receiving it, obviously, because we have the API ready, but we don't have that sent anywhere. We don't have the response published. So let's go to our network service. So in our network service, we are going to receive the send method. So the platform is going to finally get it here. So this is where we're gonna get on value map. Why don't we do a we could just add this thing here right away, but why don't we just introduce one more operator here? Well, you know what, why don't we just send it here, send it over here. Let response equal to, let's propose the response. The response let's weak self, because we wanted to do weak self here. Network response, return this response here, self dot event stream dot publish this event response response. All right, so we have a try map operator. That try map operator actually parses the data and then response. When I say parse, I mean just an error or not, that's the parsing. We're not parsing the data into a API model. We're just, you know, analyzing the response, right? So if that response is okay, then we know, you know, we're cooking a new response object, network response object, and then we're returning back to that try map operator. The try map operator, then send that value to the downstream and then back to the consumer. But before we return that response, we wanted to send that response back to the error stream, even stream, right? Okay, so now this logic is added. Let's see if our tests are passing. Event. Nice. Okay, right? So now we're sent the response. So now it's obviously is going to pass. Let's see our code coverage. 100. Okay, so we want to make sure that the network service reaches here. Obviously it's going to reach because yeah, it reaches here. Sounds good. Yeah, right. So we're reaching here. That is good. We're still 100% code coverage. Okay, so now we have two use cases covered. So let's implement our final use case for the logging. Given a network service, when an error occurred during network call. Oh, come on. Call, then the error is emitted to error publisher. Right? Sounds good. So it's all the same. We're going to copy all the thing. So this time, what I'm going to do is that I'm going to say, hey, if it is a request address, oh, you know what? A request is fine. If it is a response, I'm going to say, hey, we're not expecting a response. Fail. Shouldn't receive response, right? We're gonna expect a error here, event receive. That's what we're gonna expect. So let's move this guy here as well. If we are expect error, case. So let's fail this guy as well, because in the previous test we are expecting a response. Error. Okay, this is fine, this is fine. In the above one we can just ignore it. All right, so this is the kind of setup that we need. So okay, so if we receive a response, that is fine. Okay, sounds good. So let's build this thing. Obviously it's going to fail because we don't have any case added here. So now we go and then add a case. Network error. We have an object called network error, and then this network error has some underlying error and status code and everything, all the usual stuff. So now let's build this guy. Build is success. Let's run it. Obviously this is going to fail. Yes, because it receives a response. That is also a fail, and it's also didn't receive an error. So that means we are receiving a response, right? So what's happening is that our mock URL session is by default set up to send a send a success response. So what we wanted to do here is that before we trigger an API call or trigger a service call, we wanted to tell the mock platform, hey, this time you fail the request, right? So I'm going to say results equal to failure with the, I don't know, probably URL error with the code bad server response, right? I'm going to fail it. Let's just see. Okay, so this time it did did not receive a response, which is a good thing, but it didn't receive the error. Oh yeah, because, yeah, correct. So this is fine because in our production code, we are not actually emitting an error. So let's go and then fix that one. Okay. Let's see. Okay, we have a map error here. Okay, let's see network error. Error, then I'm going to say network error is equal to existing error, else I'm going to cook it. Okay, now we have a network error. Before I send the network error, I'm going to return back that. Make sure to, you know, wikify ourselves because you don't want to end up in a retain cycle here. So what I'm going to do here is self.event stream.publish this event dot error network error. Okay, let's see if it's building. Nice. Okay, let's test this. This should pass the test. All right, there you have it, guys. Let's analyze the network code coverage. So there's still 100% code coverage, right? So we have implemented, so far we have implemented these 3 use cases in this video. So sending the request, sending the response, and sending the error to a publisher. So if we do it this way, let's go back to the original question, right? So we're talking about logging, right? So if we do it this way, the network library, it does not have to concern anything with logging, but the consumer of the library, they can create an adapter between network service and then the logging, and then just send that, you know, published events to logging API, right? So then if let's re-implement this one, right? So let's just say instead of network, I am an app target, right? So since it's an app target, this app target will have access to login at the same time network as well, right? So let's just say in our, if we have one of a class called a bootstrap or something like that, or let's just call, you know, a configuration, you know, service configuration setups, or yeah, you know what, call it, I like the word bootstrap. You know what, why don't we call it bootstrap? I like the word bootstrap. I learned this word from my previous companies. I really like it. Like, let's just say we have a bootstrap call, a function called configure logging logs. So this guy will create a service network builder, and this guy is going to create a components, right? Build dot publisher, right? This is how right? So the consumer is going to use network service builder to build a network component, and then from the network component they're going to obtain event publisher. So this event publisher is going to produce a sync method. The sync method is going to contain the events, right? So now I can write a switch method here. Switch method case request if I receive a request event, then logger dot log request value, you know, on parameter or log level. right? So we can just write like this. Again, this is pseudocode. Down the line, I'm planning on writing a feature model as well. In that feature model, I can just, do all the implementation. For now, I'm just, writing this pseudocode. All this idea. This is how I have done this in the past. Right, so like this, right? So we can just do that. So the bootstrap can be called from app delegate. Launch blah blah blah. From there, in fact, this can be bootstrap bootstrap.configure network logs, right? So instead of creating a builder right over here, so obviously I'm just writing this time I'm creating a single instance. If I call this method, a new instance of network service is going to be created, but that's not the service that we're going to use. Probably we wanted to store this service somewhere. Lazy service or components, right? Network components. This network components will have a event publisher, right? This is how we wanted to write. So that way we can just reuse this network component and then send the service object to all our feature model, right? So that way all the services are stored in one place called bootstrap, or we can just call it some other thing. I don't know. In different projects in the past, I've seen somebody call sometimes people call the service manager, somebody call it a dependency manager, things like that. You can call whatever you want in your code, but this is the general idea how we're going to implement, right? So if you notice that this logging library, it does not know anything about networking. At the same time, the networking does not know anything about logging as well, right? So, but we're creating a adapter in our app target. The reason I chose app target is because this app target usually is the place where we add all our libraries into, right? All our libraries are going to be embedded in app target. So that app target will know the API of both libraries. So it is the best place to create all our adapters, right? You create an adapter and then create a connection between these two core libraries. You have a nice library setup that is a stable libraries. Even logging library is going to be stable. It is not going to be destabilized by anything else. Network library is also going to be stable because it's not going to be destabilized by any external dependency, right? So this is how we do it. Sounds good, right? So this is nice and clean. This I really like about a test-driven development, because it forces us to think about how to pass the test. In order to pass the test, we need to think about how best we can abstract everything around our business logic, which is a domain logic. And also, since we are practicing writing use cases as a test, our business use cases are also implemented, right? I really like this development process. Anyway, there you have it. So let me run the test one more time to make sure we have a good code coverage. Okay, there you have it, right? So we have 100% code coverage again. Let me zoom here. You see all the things are 100%. Not now, right? All the things are 100% code coverage. Even our test utilities, they also 100% code coverage, but it's not. It's a minor, which is only one class, right? Anyway, guys. So there you have it. Thanks for watching this video. I will talk to you guys in next video then. Thank you very much.